Hey, what's up, YouTube fans? So what I wanted to talk about in this video, right, is how, something I've talked about before, right, is how the limbs of tetrapods, right, it's the same fundamental structure in all tetrapod groups that have the limbs, even though functionally, right, they're used for very differing purposes, right, which therefore helps significantly in demonstrating the reducibility of the limbs of differing tetrapod groups, right? Because it shows that it doesn't have to every step along the way have the function that is currently used for in order to have any useful function at all, right? Because this same fundamental structure can be modified towards so many different uses. Primates such as humans have limbs modified towards tree climbing. Bats and birds use them for flying. Whales use them for swimming. And many creatures use them for just moving around terrestrially, right? Moving around on the ground, dogs use them for that purpose. Even us, we use our limbs for moving around on the ground. Aside from the other purposes we use them for, we use them for walking around on the ground. So do many animals. But what I further wanted to talk about in this video, right, also, right, is how even amongst tetrapod groups that functionally use their limbs for the same purpose, right, which parts of the limbs are used for which part of that can still differ, right? Which further shows the reducibility and that it doesn't have to, from the start have its current function in order to have any use at all, right? And so, for example, right, for creatures that use their limbs for walking around on the ground, right, which parts are used for like the function of the foot, for example, like functionally, that can differ between different groups, right? So, for example, humans and birds, right? We both have legs and feet, which we use for walking around on the ground, right? And yet, functionally, which part is used as the foot is different in us versus them, right? Because you see, if you look closely, if you watch a bird walking around, for almost all birds, what you'll notice is that it actually looks as though their legs bend backwards, right? Like in the opposite direction of how our legs bend, right? But it's actually not that their legs bend backwards, but rather what's happening is that it's actually that their feet are really long and they stand on their toes, right? And so basically, only part of their foot is used for like the function that we use our feet for like walking on it, right? Whereas the rest of their foot, just like they don't like rest on the ground when they walk around. It's just like it functions more like as if it's just like another part of their leg, right? Not the part that like we would use as our like. So basically, when an animal is like that, it's called digitigrade, right? When they walk on their toes. We also see that in dogs and cats. So if you have a pet dog or a pet cat, if you look at their legs and feet, especially the back ones, what you'll notice, right, is the same as with birds, that it looks as though their legs are bending backwards. But again, it's not that their legs are bending backwards, right, but rather they're standing on their toes, right, and they just have really long feet. Not as long of feet as birds, right, but still kind of long feet. And then also you'll notice that it looks kind of like that also in ungulates, the hoofed animals, right? In them it looks as though their legs are bending backwards. But in them it's actually not called digitigrade, it's called unguligrade, because they're walking on their hooves, right? So it's called unguligrade, right? But again, like these other groups, it's not that their legs are actually bending backwards, but rather they just have really long feet, which most of the foot isn't actually like touching the ground when they move, right? Whereas for us, since our whole foot makes contact with the ground when we walk, creatures like us, it's called plantigrade, right? And so, even though it's the same fundamental parts, right, for all of these different groups, and even though functionally we're all of these groups are using it for terrestrial movement, walking around on the ground, the like which parts are used for which purposes, like which part is more so functioning as a foot, that differs between these different groups, right? Which just further shows the reducibility of it, and that it doesn't have to have always been the way that it is for us in order to have any use at all, right? And so, the ancestral structure can be modified again and again and again just through basic adaptation, but, again and again, adapting again and again and again, giving us all of these differing setups of the limbs, right, within differing tetrapod groups, but from this same ancestral structure. Also worth noting is, so like in bats and birds, since bats and birds evolved their wings independently, right, which is what we would predict based on that, bats are mammals, whereas birds are not. So bats are actually more closely related to us. That alone would make us predict that they would have evolved their wings independently. And so we would therefore expect that they would have that we would expect to find fundamental differences in the bat wing versus the bird wing. And we very much do, right? So if you look at a bat skeleton and versus a bird skeleton, you will immediately see very significant difference of the structure of the wings, right? Because birds do not have as many fingers as bats do. Their fingers are much more reduced, and not having as much like skin and muscle filled in between them. It's hard to fully describe, but if you look at the skeletons, it's very clear to see the difference, right? And so they evolved very significant fundamental differences of their wings, even though they both evolved wings, but the type of structure of the wings is very different. And that's exactly what we would predict based on that. We already know that bats are mammals and birds are not mammals, right? So that alone would make us predict that bats are more closely related to us than they are to birds. That alone would make us predict that they would have very different wings from birds, right? even though the wings themselves are not a mammal trait, right? But based on that reasoning, we would predict that they would have very different wings from each other, and they certainly do, right? It's very clear to see if you look at their skeletons, you'll see it immediately. There's very clear difference between their wings. Their wings are very different. Um, in any event, that's all for now. See you guys.